Hello, everyone. Welcome back. My name is Cureton, Senior Journalist for XR Today, and as always, we're bringing you the latest and greatest from the VR, AR, and XR industries. Today, we're going to have a very interesting dialogue with Mr. Fabio Murra. He is the Senior Vice President of Products and Marketing for VNova, and we're going to talk a little bit about what VNova does. They're making an amazing kind of solution that's actually integrated into a lot of different immersive headsets and devices. So thanks for coming on today, Fabio. It's a pleasure to meet you.
Thank you for having me, Timon. Thank you.
All right, brilliant. So we will talk a little bit about yourself. Could you introduce what you do with VNova and what is VNova's mission?
Yeah, let me introduce myself as well. My name is Fabio Murra. I've been with VNova since kind of the very beginning, 8 years ago. We started a company with the mission to improve the way in which data, not just video, but the data is kind of compressed and shared between application to increase the experiences that are more and more immersive for the final user. At VNova, we are a company that does, we describe ourselves as an IP and software company. So we develop technologies, we develop algorithms that eventually become standards. So we have promoted and are behind the technologies that is used currently in two standards, one by MPEG and one by SIMTI, the Society of Motion Television Engineers. And we're working on more. For example, point cloud compression. It's one of the latest technologies to be standardized to kind of deliver and render immersive spaces. But as well as developing the algorithms, we also develop solutions. So we have software solutions, hardware solutions that then end up in anything from browsers to mobile handsets to mounted displays, head-mounted displays to deliver and these better immersive experiences. Personally, I've been in video compression kind of all my working life since the days of university. The field has developed a lot, but always with it's always been incremental in a way, right? From the very first MPEG technologies that gave us digital television in the 90s to before VNova and LCEVC has always been incremental improvements of the same foundational technologies, right? With LCEVC and our other technologies, what we set out to do is develop and deploy a new approach to video compression. This is fundamentally what we did, what we're trying to do, because we fundamentally believe that there was a level of redesign to do in order to deliver the efficiencies that are needed today to kind of deliver the immersive experiences that are quite demanding on video compression that we need today. In a nutshell.
Yeah, that's excellent answers. And so we look into a lot of these technologies. So we have many immersive headsets coming out. We have the MetaQuest Pro, the Pico 4, Pico 4 Enterprise. We have HTC Focus 3. A lot of new headsets are developing technologies, but with LCEVC, which is your main product from VNova, we try to solve some challenges in developing these technologies. So how does LCEVC aim to tackle some of the challenges in video compression with immersive technologies? Like, what does it try to solve?
Yeah, it's a very good question. The problems of delivering high quality video or high quality immersive experiences, particularly relevant to displays and head-mounted displays, but also they're made particularly obvious, let's say, right? Head-mounted displays, they're getting better, more capable, higher resolution, lighter, but there's still a fairly heavy compute device on your face, right? So, but the trend is of having lighter and lighter head-mounted devices to deliver a higher and higher quality experience, right? On one hand, we want lighter devices with little compute. On the other, we don't want to be tethered to a machine. But on the other hand, we want experiences that are as good as quality as the world around us, right? And there's these two kind of opposing requirements in a way is where the predicament is, right? Do I render the virtual world on my head-mounted display and therefore have a high power, high cost unit, or do I deliver low quality? Neither of them is the right answer. So where LCEVC comes into use here, it's the solution to deliver the highest quality video to a head-mounted display. So the idea is really we untether the display from the rendering engine, so from the engine kind of rendering the virtual world, and the display unit you have on your person, right? And that world could be rendered in the cloud, could be rendered on your PC, could be rendered anywhere and delivered in real time over a wireless network to your very light head-mounted display. So on one hand, you need an engine that delivers photorealistic experiences, super high quality, super resolution, high frame rates. And on the other hand, you need a technology that is light enough to fit in the computing capabilities of a pair of light glasses, right? And the idea is that LCEVC, low complexity enhancement video coding, is the technology that enables to do that. And we have many experiments, many trials, many proof of concept currently that we're doing with various companies, big companies in this space, to really demonstrate how you can take a 4K or bigger than 4K virtual world, render it in real time in a cloud, and deliver it with very low latency at the bandwidths that are necessary, on a kind of Wi-Fi network in your home, to a very light head-mounted display.
Absolutely. And it's very interesting how you can create these solutions and then it helps out the entire industry, because it will help you kind of apply these technologies to fill in where the headsets are unable to kind of render the video, or to get the kind of how I would call it, like a sweet spot for video compression. So for example, like we look at some of the older technologies, like not necessarily legacy technologies, but more of the H.264, H.265 kind of codecs that have been previously used with these technologies and that are currently being used today. Now, when vNova steps in, how does it actually work with these different codecs to deliver this solution?
So you said it. How does it work with these technologies? And there's often a misconception that you have to kind of rip out everything you put in place before in order to deploy a new technologies. And traditionally it's been like that, because you're tied to the availability of that technology in a piece of silicon on a chipset that therefore have to be available in mass quantities in the market. Where LCEVC is different is, it's an enhancement, is in the name, low complexity enhancement video coding. So it's not a standalone technology, but it's used together with the ones you mentioned, AVC, HEVC, and AV1. It is used together with these technologies to get better performance out of them. And it's also low complexity, meaning it can be deployed in software on devices existing today by simply using blocks that are there. They're fundamentally there. CPUs, GPUs, scalers, blenders, they're all blocks available in silicon today that with LCEVC we can use to basically deploy the technology in software. So where we're working, whether it's in the XR space or in streaming or in broadcast or in many of the other kind of industries that we're active in, is basically we're working together with our partners to make sure that we deploy LCEVC in a way to get the kind of best bang for their buck on their existing kind of video delivery infrastructure. So, in the XR space, you have companies like NVIDIA, AMD, and Meta, of course, that are all developing kind of end-to-end solution to deliver these worlds, but they're all fundamentally render something, a world in the cloud, encoded with a technology. And whether it's AVC, HEVC, or in the future AV1, we're working to get the performance that is necessary to squeeze that virtual world through the bandwidth that are available in the home, which is typically, regardless of the fiber connectivity or not, you're in a wireless environment, you're moving, your distance from your router varies. So, you can rely on 30, 40, 50 megabits a second if you don't want to be kind of constrained in space or tethered to something, which is kind of like, prevents the enjoyment or the realistic enjoyment of the virtual environment. And we're doing that obviously in low latency, with the best possible quality, with the best possible frame rate. Again, it's an enhancement, right? It's allowing the step up in solutions that are already developing in the market to deliver XR experiences in real time to consumers.
Absolutely. Yeah, and it's that kind of collaboration, that interoperability with current and existing solutions that's going to help it to go a lot further than creating proprietary systems that work only with a select few devices. So I think companies developing these types of systems will do a lot more for the entire XR ecosystem in the future. Speaking of which, ecosystem, we speak about that. There are a lot of different perks to using things like LCEVC, along with, there's improved pixels, improved battery life performance. I was curious though, wanted to know if there were any environmentally friendly benefits to using the technology. Like, would it save, electricity costs or things like that? Would it help to prolong the battery life of the headsets? What can you tell us about that?
Yeah, and the short answer is both, and we have data that shows that as well. Let me start by saying that video is expensive in general, right? In terms of data to be encoded and transmitted is a lot heavier than audio, web pages, files, whatever. It constitutes, a large proportion of today's traffic on the internet. And if you're thinking of making kind of XR metaverse-like experiences, mass markets, where you have millions of concurrent users constantly accessing streams that are personalized, because that's your own view of a virtual space at high resolution and high frame rate, you can see how the volume of video on the internet is only going to increase. And producing and compressing this video will put a strain on the data center. So any technology that lightens the load on the data center, that prolongs battery life, it's worth looking at, I would say. Right? The problem is kind of that trade-off between the compression efficiency and the computational requirements that are typically, in the space, right? The various codecs. Let me rephrase it. Various codecs over the years have become more and more and more efficient, but also more and more computationally intensive. So deploying a AV1 encoder certainly reduces the bandwidth by, let's say, 50% compared to its predecessor, but is also 10x more expensive in the data center. So this is why we set out, and not just by ourselves, we did publish a paper as Vinova together with Intel and Meta, analyzing the performance of different codecs and different codecs with and without LCEVC across we did about 650,000 encodes to measure the computational and compression performance at different operating points. And what we found, and this paper is available on the SPIE website or our vinova.com website, I think it's available on lcvc.org as well, if someone wants to have a look at it. But fundamentally, the net result is that using LCEVC, even with the most advanced codecs like AV1, will improve the compression efficiency, but also will improve the computational efficiency by over 80%. So, and that's a massive number, because if you think about, how much cost that is in the data center, how much electricity, or how many more stream you can process on a given physical asset, a server that consumes so many watts, it has a real impact on the operational costs for the service and the data center operator, but also a net benefit environmentally, right?
Yeah. And I know that with so many companies using their kind of like consumer responsibility like programs and trying to meet UN sustainable development goals, this is a very key technology that could help digitally transform a lot of different enterprises. So that way, as they do that, they will be able to consult with this technology and achieve that goal, because they have to put out tangible measurements and report those back. So very interesting point that you made there. I wanted to ask you a little bit, because there's so many things happening in the industry at the current moment. We have the different headsets that were mentioned before, and many of them are now working with other companies to try to create new solutions to, I guess, expand how people use their own solutions. For example, Meta Platforms work with Microsoft to make cross compatibility for Teams and Office 365 and other types of technologies. Have you seen anything in the, I suppose, in the industry that has really caught your attention, and something that you'd like to talk about regarding the development of XR?
Well, I can speak about a couple of first-hand experiences, right? The topic of collaboration is is a very interesting one in general, because there's two sides to it. There's people collaborating in drafting standards, so drafting recipes that then everybody else will implement, and eventually they will seed the market with the technology. And we've been involved in that, working with hundreds of companies to develop LCEVC as a standard, right? On the other hand, you have Meta collaborating with Microsoft. We have AMD collaborating with Microsoft. AMD collaborating with Microsoft and Meta to kind of now accelerate a market to respond to consumer demand fundamentally, right? And build solution that can answer a question, a demand. And firsthand, I mentioned the paper that we did together with Vinnova, Intel, and Meta. There are three very different companies, and three companies that could have a very different role in the XR space, but they all have a role, right? So if you put the service provider, the provider of the hardware, silicon, and overall kind of software solutions, and a technology provider, you kind of build a value chain that when pointed to a specific result, whether it's assessing the value of LCEVC with AV1 or building an end-to-end the best end-to-end XR experience that we could have today, you can see how that value chain can accelerate a result, right? And we have another example specific to the metaverse with another company called Red Pill VR, with whom we're collaborating. Red Pill VR is a very interesting company offering a metaverse kind of joint experience to its users, to that varies from clubs to concerts. And I can see the high value of such experiences, but in order to be effective, they need to be at scale. So we're working with them as a final user of this value chain to ensure that they can get there as quickly as possible. And in Brazil, we're working together with other big companies there to deliver next generation digital TV services. So I really appreciate that ecosystem. It kind of is needs to be born from collaboration. Actually, just to mention one last thing, at IBC, the broadcast show in Amsterdam this September, we didn't go as Vinnova. We went as a sponsor of an LCEVC showcase. And why? Because it's limiting having Vinova and having Red Pill VR and having another company, Nvidia, let's say, all showing bits of solutions for the XR space. And so we went with an LCEVC showcase showing real end-to-end solutions. And together with Nvidia, with a company called Presence, for example, we had a kind of photorealistic 6 degree of freedom live rendering of a short movie. It was a 12-minute movie in 6 degree of freedom on a standard gaming laptop, which was a first. Where in this case we were using point cloud compression, so a kind of the big brother of LCEVC, if you want. But it's another one of those things where I could talk about point cloud compression, all day, and still having you fail to grasp the impact that this could have on a user experience. But when I combine it together with an NVIDIA GPU on a standard laptop using present software, I can take any graphic engine and turn it into a fully immersive 6 degree of freedom. So you're not anymore with a point of view, but you're in a cube and you really can move around and be part of the scene, all on consumer hardware. And it's a much better way to obviously showcase the technologies, but also accelerate their time to market.
Absolutely. Yeah, and there's so many different possibilities like with the technology. And I think that as people collaborate and experiment, they'll be able to find new use cases for it. So, we'll see how it develops. As I always tell people, we'll see how it develops in the future. But yeah, for the here and now, I think that there's a lot of prospective things that we can do with LCEVC. So yeah, any final comments or anything else do you like to say before we close up for today?
Yeah. My final comment is, I think, perhaps on the timing of these things in the future versus, what we have today. I think we're a bit on that inflection point where some of these experiences are now almost kind of ready to be, decoupled to the kind of gamer as the final users and really become mass market. Right? What I mentioned is us working with some of these companies, not because 3D VR for a game doesn't work. It works if you have a desktop machine, kind of computing capabilities, and for that part of the market and that niche user, it works, right? But if we want to make them really mass market, hit the millions of users, occasional users that will want to step in and out of these experiences, then we need to deliver them uncoupled for the final headsets. We need to deliver them in the cloud or edge cloud. We need to deliver them as efficiently as possible, obviously for the user to be able to consume them, but also for the services and the enterprises to be doing so sustainably, right? Both for the environment, but also from a cost of ownership perspective. And therefore, in order to make that mass market possible, we need to look at the technologies that can enable these aspects, right? And we believe firmly, and we're working with all these companies to prove it, that LCEVC is one of these technologies that can compress better, decode lighter, and deliver kind of like cost savings on one side and better experiences for the users.
Right. Excellent words. So thanks so much for joining us. And once again, we've been speaking to Fabio Murra. He is the Senior Vice President of Products and Marketing for Vinova, who has developed the LCEVC kind of compression tool that is helping immersive technologies to build better experiences with lighter impacts on the environment, as well as on the headsets and devices that are running them. And once again, if you'd like to follow conversations like this, please go to the XR News hashtag on Twitter and LinkedIn. Once again, my name is Cureton, Senior Journalist for XR Today. Thanks again, Fabio, for your time today. It's been an absolute pleasure speaking with you.
No, thank you. Thank you for having me.
Okay, wonderful. Thanks again, everyone, guys, for tuning in for today. We will see you and catch you at the next go-around. Until then, take care and bye now.